Okay, welcome back to our grade 10 maths lessons. I'm Miss Awinup, your maths teacher. In our last lesson, we looked at simplifying surds. In today's lesson, okay, we're going to add and subtract surds. Okay, we're adding and subtracting surds. Okay, now let's review first of all what we did in our last lesson when we were simplifying surds. Okay, let's have a look at a number like 1,600. All right. So this is a surd. We have a radical sign here, square root of 1,600. Okay. Now, in order to simplify this number, we need to break this number into two factors of 1,600, making sure that one of the factors is a square number. Okay. In this case here, you will find that we are going to use 16, okay, times 100. Now, this number is, in fact, a good number. We broke it up, but we have two square numbers. So if we're simplifying this, we are going to take the square root of 16 multiplied by the square root of 100 to give us 4 times 10, which is equal to 40. Okay, so we've simplified the radical here, square root of 1,600, simplified here so that we find the root of this number, which is 40. Okay, so this same idea we are going to be using when we add and subtract surds. Okay, now one thing we must remember about surds, just as we did in algebra where we are adding and subtracting like terms, we also practice that idea when we are adding and subtracting radicals. Okay, now let's look at the numbers root 7, or let's say a root 7, or half root 7. Okay, all these numbers are like terms. They are like terms because the number under the radical sign is the same. Okay, now unlike terms would be numbers that are different, root 2, root 3. Okay, we can have an algebraic term underneath a radical sign like a. Okay, so all the numbers under the radical are not the same, so these are referred to as unlike terms. Okay, unlike terms. Right, so we are using simplifying of surds. We keep in mind like terms and unlike terms. So now we're going to use an example to show how we are going to add and subtract like terms. Okay, so example number 1, we'll start with an easy one and then move into trickier examples. Okay, so let's look at 3 root 6 plus 17 root 6 minus 2 root 6. Okay, now we have the radical sign that has the number 6 under each of them. That makes them like terms. So the rule for adding and subtracting surds is that we add or subtract the coefficient of the radical. Okay, so the radical remains as it is, and we work with the numbers that are in front of it. All right, so we have 3 root 6 plus 17 root 6. So we write 3 plus 17 root 6 minus 2 root 6. Okay, this becomes 20 root 6 minus 2 root 6. Okay, now we are going to do the subtraction bit. So 20 minus 2 root 6. And our final answer is 18 root 6. Okay, now we cannot simplify this any further. So this becomes the final answer to the addition and subtraction of these radicals here. Okay? Now, let's move into something a little bit more simplifying, okay? We can say. So example number 2, let's try this. 5√3 plus 2√12, okay, minus 5√2 plus 3√8, okay? Now you can see a collection of numbers under the radical sign. We have √3 here, √12, √2, and √8, okay? So before you start, you need to look at the numbers and see if you can simplify, all right? In order to simplify, remember, we have to break that number up into 2 factors, one which is a square number and another which is not, okay? So let's move out this way so we have enough space, okay? 5√3 cannot be simplified, so it stays as it is. Plus, we have √12 here, which we can simplify. So we write 2. √12 here becomes √4 times √3. Okay, remember, one number has to be a perfect square. Minus 5√2 plus 3√4 times √2. Okay? Now, once we have simplified, we now continue to the next step. Okay? 5√3 stays as it is. Okay? Plus 2 and √4, okay? Square root of 4 is 2, so you bring 2 here and multiply by the number that was outside the radical, and radical remains as √3, okay? Minus 5√2 plus 3, again, square root of 4 is 2, so that comes out, multiply by 3, and √2 remains as it is, okay? Now, we are simplifying, and because we are multiplying here, that multiplication continues into the next step, okay? Now, let's get rid of all these brackets here. 5√3 plus 2 times 2 is 4, √3 minus 5√2 plus 3 times 2 is 6, √2. Okay, so we have completed the simplifying bit. Once that's done, we are going to add and subtract, okay? Now, like terms here are now 5√3 and 4√3, and negative 5√2 and positive 6√2, okay? So, like we did in the first example, we only work with a number that's in front of the radical sign. So 5 plus 4 will give us 9, √3. Okay, negative 5 plus 6 will give us positive 1. So this becomes plus 1, √2. Now remember, in math, wherever there is 1 as a coefficient, we don't need to write it. So our final answer here is 9 √3 plus √2. Okay? Again, we cannot simplify. So this is our final answer to the addition and subtraction of the radicals here. Okay. So let's look at example number 3. Okay. And this time we're going to use algebra with the radicals here. And let's see how we're going to work this out. Okay, so we have half multiplied by √100 a cubed, okay, b squared plus ab √36a minus 5 root 4a squared b. Okay, all under the root sign. All right, let's see. We have algebraic terms AB, AB. Okay, now like I said, when you are simplifying, the idea is the same. You need to break the numbers up so that you have a square number and a number that's not a square, making sure that they are factors of that number. Okay, so 100 here is a perfect square. So we write this down. We're going to list everything down so we can see where I am simplifying. So 100, half of the square root of 100, okay, multiplied by a cubed can be factorized to a squared times a, okay, a square number and one that's not, okay, multiplied by b squared, okay, plus ab. 36 can be factorized as 6 times 6. So that's a perfect square. We have root of 36 times a minus, again, 4 is a perfect square. So we have root 4a squared times b. Okay, so we've broken these numbers up to a square number multiplied by another factor. Okay, let's move on. Square root of 100 will be 10. So that 10 comes outside, okay, the radical sign. The square root of a squared is a, okay, and the square root of b squared is b. So what we have left under the radical sign is this a here. So that stays as it is. All right. Follow me closely. This is going to get tricky. Okay. Now here, AB stays where it is. 36 is a perfect square, so the root of 36 is 6. That goes outside. And we have a left, which remains under the radical sign. Okay? Minus 5. 4a squared is a square number. All right? So the root of 4 is 2. The square root of a squared is a. And what's left under the radical sign is root b. Okay? So we've simplified all the numbers here that can be simplified. All right? Now we remove these brackets here. So we have half of 10, which is 5, multiplied by AB will be 5AB root A, okay, plus AB times 6 will give us 6AB root A minus 5 times 2 is 10 times A will give us 10A root B. All right. So once we remove those brackets, we are now able to see which terms are like terms and which ones are not like terms. So we have root A here and here. So that makes these two terms like terms. This one, unlike term. Okay. So addition will take place only here. 5AB plus 6AB will give us 11AB times root A minus 10A root B. Now you may think that there's A here and A here and that will make it like terms, but that's not true. We have B also attached to A, so that means it is not related to this term here. Okay? So once you reach this stage, check again if any numbers can be simplified. If it cannot be simplified, then you have reached the final answer. Okay? So 11ab root a minus 10a root b is the answer to the addition and subtraction of these radicals. Okay? Now, I hope you've learned something here, and I hope the lesson has been easy for you to follow. In our next lesson, we're going to look at multiplication and division of surds. I hope you can join me then.